Hello everyone, I think we got a new circuit here. Not that one, that's my iPhone 4. These two. We have two circuits here. What is this circuit? Ah, we have here two transistor circuit. This one and this one. This is a 12 volts transistor circuit connected to my power supply, 12 volts, the blinking white. And this one is my 5 volts transistor circuit connected to a 5 volts, the blinking blue. So what is these two circuits? It seems it's the same, just an LED circuit, but in a circuit diagram it's different. Let us see the circuit. Okay, where is the circuit? Oh, not that one. So here is the circuit. The circuit of this one is this transistor circuit open base. We have the transistor here, a power supply, a switch, a resistor, and an LED. This is the circuit diagram. And the other one we have here, the circuit of this is this transistor circuit design, no pull down resistor. So this is my previous project. I just made it and computed all the values of the resistor here. As we have seen here, this is just an ordinary transistor circuit. The voltage supply here, current flows here to the collector and to the ground, emitter to the ground, and also flows here to the base, to the emitter, and to the ground. In here, we reverse the voltage supply. See? We reverse the voltage supply here, and the switch is here. And then the current flows here to the resistor, to the LED, and to the emitter, and to the collector. The collector now is grounded, and the base here is hanging or not connected. So why is it that this transistor circuit is functioning? See, it seems that there is a reverse voltage supply here with the switch, and then the current flows to the LED and then to the ground, short-circuiting this transistor. So that is what we call a reverse breakdown voltage is happening here. That is the features of this circuit. We have the collector emitter with open base. The breakdown voltage of the transistor I'm using is 222A 40 volts. And the existence of this negative resistance. It seems that this circuit is breaking the law of Ohm's law. Unlike here, this is just the proper way of making a transistor circuit. The LED is connected to the collector side and then to the ground with the base resistance here. But in here, there's no base resistance. It's an open base. So the current flows here. There's a reverse voltage here. So you can make a transistor circuit without a base resistor here. Thus still the current flows from emitter to collector. This is an emitter side, and this is what we call a negative resistance. So still the current flows from emitter to collector. I think in school there's no such thing as teaching you such negative resistance, but in the real world there is it. There is a transistor circuit like this, and it's functioning. You can try this. See, reverse voltage supply here. When the switch is closed, current flows here to the LED and to the transistor. Even the base of the transistor is hanging, or it has no connection. There is some sort of negative resistance here. Still the current or the electron flows from emitter to collector, making a closed circuit here, denoted by this orange line. So we can compute now the value of the resistor here to protect the LED from burning using Kirchhoff's voltage law. Voltage supply minus the voltage of resistor minus voltage of the light equals 0. Kirchhoff's voltage law or KVL is here. The voltage drop across the resistor is 12 volts minus 2 volts. 2 volts is the data sheet of the LED that is given, and then we have the voltage drop across the resistor is 10 volts. And using Ohm's law, we have B is equal to IR, and our resistor here value is 10 volts divided by 0.02 ampere. That is the current flowing in the resistor in series with the LED is the same according to Ohm's law. Current in the LED is the same as the current in the resistor, and it is the given on a data sheet of an LED 0.02 ampere. We computed already the voltage drop across the resistor 10 volts here, and then we got now a value of resistor 500 ohms. The value of is 500 ohms to prevent the LED from burning. What I use 1 kilo ohm resistor. That's my available resistor, and also I have a reason for that. Using this power formula, power of the resistor is equal to voltage times the current. Power of the resistor, or the heat, or the power used by the resistor is voltage times current. 10 volts times 0.02 ampere. The resistor is using 0.2 watt. That is the heat dissipated in the resistor. 0.2 watt. If I'm using 500 ohms here, 1/4 watt. 1/4 watt is equivalent to 0.25 watt. And I experienced that when I'm using this 500 ohms, the resistor is getting hot. So I use 1 kilo ohm 1/4 watt resistor instead of this 500 ohm, because the power dissipated in the resistor is 0.2 watt. So this is the 222A pin out configuration, and then we have here EBC. That is the flat side facing us. And then the parts we use is the transistor here, the resistor, the voltage supply, and the perf board. So the features of this is I'm using here 222A instead of this normal transistor circuit C2878, because this 222A has a reverse voltage of 40 volts. If I'm using this C2878, it has a reverse voltage of 20 volts, and I tried that and it's not working, so I replaced that C2878 with this 222A. And now we have a new transistor circuit here with the reverse voltage supply and the reverse connection of the transistor here. The collector is connected to the ground and the emitter side is in here, connected to the LED. Instead of here, the collector side LED is in here, and the ground here is the emitter. This is the normal way of making transistor circuit. This is other way. This is what we call the negative resistance phenomenon happening in this circuit. So we got here, actually out of my previous project here is this one, and this small one is this. We get now here the values by 1 kilo ohm, and we got this actual circuit here layout. Okay, that's our new transistor circuit, and thank you for watching my video. Bye bye.